So now we will discuss major and minor tricks. We'll save the new file by the name major and minor tricks. So within each axis there is the concept of a major tick mark and a minor tick mark. As the names would imply, major ticks are usually bigger or more pronounced, while minor ticks are usually smaller. By default, Matplotlib rarely makes use of minor ticks, but one place you can see them is within logarithmic plots. So as usual, we'll start with this, and now we will do ax is equals to plt dot x scale log y scale. So we have this, and we see here that each major tick shows a large tick mark and a label, while each minor tick shows a smaller tick mark with no label. We can customize these tick properties, that is locations and labels, by setting the formatter and locator objects of each axis. Let's examine these for the x-axis of the plot just shown here. Now print ax dot get major locator. We will copy this and we will paste this. Minor. And now we will do print. We will change this to formatter. Formatter. Print. Formatter, but it will be minor. So we see that both major and minor tick labels have their location specified by a log locator, which makes sense for a logarithmic plot. Minor ticks, though, have their labels formatted by a null formatter. This says that no labels will be shown. We'll now show a few examples of setting these locators and formatters for various plots. We'll discuss hiding ticks or labels. So perhaps the most common tick or label formatting operation is the act of hiding ticks or labels. We can do this using plt.nullLocator and plt.nullFormatter as shown here. Let me show you. X equals to plt dot plot and p dot rand 50 ax dot y axis dot set major locator plt dot null locator ax dot x-axis dot set major formatter plt null formatter. So we have this, and notice that we have removed the labels but kept the ticks grid lines from the x-axis and removed the ticks and thus the labels as well from the y-axis. Having no ticks at all can be useful in many situations. For example, when you want to show a grid of images, for instance, let me show a figure which includes images of different faces, an example often used in supervised machine learning problems. Let me show you. big ex blt dot subplots 5 5 big size 5 big subplots just its space 0 space. Got some face data from the scikit-learn from sklearn datasets. Import fetch olive TTI faces fetch faces images. Now for I in range for j in range ex j x-axis dot set locator blt locator ex. We will copy changing this to y. Now show show 10 I j so we'll continue. Map is equals to born. Now let's see. So we'll wait till we get the images. So you have to notice that each image has its own axis. See, they are downloading, and we have set the locators to null because the tick values, pixel number in this case, do not convey relevant information for this particular visualization. So they are downloading the images, and we'll soon have the hiding ticks within image plots. So we have these files. And you can see this very clearly.